In this video we're continuing with the topic of further integration, and we're going to look today at further integration of trigonometric functions. So again, we've previously learned how to differentiate trigonometric functions of the form sine of ax plus b and cos of ax plus b. So obviously, because we know how to differentiate it, we can then work backwards to integrate functions of this form. So if we have d by dx of sine of ax plus b, we know that the derivative is a multiplied by cos of ax plus b. So it then holds true that the integral of cos of ax plus b with respect to x is equal to 1 over sine of ax plus b plus our constant of integration for a not equal to 0. So just remember that integration is the inverse of differentiation, and that's why this holds true here. Now, this formula is given in the formula sheet in the exam, so you don't need to remember how to do that, but you do obviously need to know how to use it. Now, let's look at the other. So we've got d by dx of cos of ax plus b, and that gives us negative a multiplied by sine of ax plus b. So it then holds true that if we have the integral of sine of ax plus b with respect to x, that gives us negative 1 over a multiplied by cos of ax plus b plus our constant of integration, because we have that indefinite integral. And we know here that a cannot be equal to 0. And again, that's given in the formula sheet as well. So let's look at example 1 then. We want to find the integral of cos of 4x with respect to x. And you can see here, obviously, the argument of our cosine function is 4x. Okay, so the 4 will obviously serve a purpose here once we integrate. So we're integrating cos of 4x with respect to x. That gives us sine of 4x, and we need to divide by the coefficient of x, which is 4. So we're dividing by 4, and then we're adding our constant of integration, and that's our final answer there. So it would be a good idea to pause the video and copy down example 1 before coming back for the next lot of examples. Okay, example 2 then. This time we want to find the integral of sine of 4x plus 3 pi over 4 with respect to x. Okay, so again, you can see we've got the coefficient of x here is 4, so that will obviously serve a purpose in a moment when we integrate. Okay, and when we integrate sine, we get negative cos. So the integral here will be negative cos of 4x plus 3 pi over 4 all over 4 plus our constant of integration, because we have an indefinite integral. And again, that's our final answer. So if you pause the video, and you can take this example down in your notes before coming back for the final example of example 3. Okay, welcome back folks. And example 3, so obviously we can use the integration of trigonometric functions to find the areas as well, and we've studied that previously. So in this example, we want to find the area enclosed between the graph of y equals sine of 3x plus pi over 6, the x-axis, and the lines x equals 0 and x equals pi over 6. And you can see that shaded area is denoted in the diagram in blue. So our solution then, we should remember from before that if we're trying to find the area between a curve and the x-axis, and we can use integration to do that. And for our limits, we can use these boundaries, x equals 0 and x equals pi over 6. So we can set up our integral here. So it's the integral between 0 and pi over 6 of sine of 3x plus pi over 6 with respect to x. So integrating sine then, that gives us negative cos. So the integral becomes negative cos of 3x plus pi over 6, and we need to divide by that coefficient of x, which is 3 here. And remember, we were integrating between 0 and pi over 6. So we now need to substitute our limits in. Okay, so substitute pi over 6 in first. So it's negative cos of 3 times pi over 6 plus pi over 6 all over 3, and then we're subtracting that expression with 0 substituted in for x. So we're subtracting negative cos of 3 times 0 plus pi over 6 all over 3. So, evaluating our arguments here, we've got negative cos of 2 pi over 3, because remember this would give us 4 pi over 6, which would simplify to 2 pi over 3. So that's negative cos of 2 pi over 3 all over 3, plus cos of pi over 6 all over 3. And remember, we're adding here because in the previous line we were subtracting a negative. So cos of 2 pi over 3 is negative a half. And cos of pi over 6 is root 3 over 2. So that gives us, once we've got those exact values in, it gives us the negative of negative a half all over 3 plus root 3 over 2 all over 3, which is positive a sixth plus root 3 over 6. So that gives us 1 plus root 3 all over 6 square units, because we were working out an area, remember, and that is our final answer. So just now it would be a good idea to pause the video and take this example down in your notes before completing the assigned exercise for today.